Okay, listen up, please. All right, so the thing then that we're going to talk a little bit about today is some of the rules of exponents that we went through earlier in the class. So let's review these before we start doing some of the problems, okay? So hopefully you remember this. I don't know if you can see this or not. There we go, that's a little better. But if you have two of the same base being raised to a power, what do you do with the powers? Add them together, okay? So for example, if I had, okay, now there we go. If I had a to the m times a to the n, I would just add those together, okay? What I mean is 2 to the third times 2 to the fourth is the same thing as 2 to the seventh. Okay, which works out to be 128.
But what do you do when there's like m and n, but they have the same bases?
So they have different bases, you mean?
I mean, like, okay, they have like a, okay, well, I don't really know.
Okay, so hopefully we'll get there when we go through this, okay? Because these are all the different rules that we did. What? Nothing. Right now you're just listening and remembering, okay? All right. Then we also had a situation where you had a power to a power. And what did we do with the exponents then? Multiplied them. So 2 to the third to the second, you multiply the powers together and get 2 to the sixth. Well, do you see the difference between here and here? Between when you add? What's that?
What do you mean? Where it says am parentheses and it says equals a and then.
Okay, what I mean is, if I have x to the fifth times x to the seventh, what's my answer? X to the 12th, because 5 plus 7 is 12. Okay? But if I have x to the 5th to the 7th, what's my answer now? 35. X to the 35th. Okay? I'm just trying to review that with you. Does that make sense? Okay. The next one then is if I have two different numbers, like AB to the 7th, then the way that I do that is I just take each number inside the parentheses and raise it separately to that power.
Why?
Why? Because that's how you distribute the exponent in the parentheses.
But it's on the outside of the
But the a and the b are both inside the parentheses, so they both get raised to the 7th power.
Are we supposed to write this?
No, I'm just trying to refresh your memory before we get to the problem. Okay? Okay? Then I can also do division. If I have x to the 7th over x to the 5th, what do I do with those exponents? Subtract them. And 7 minus 5 is 2, so that would be x to the 2nd. Okay? What else did we have here that we did? Oh, you guys know the negative ones. We talked about that the other day. If I have x to the negative 5th, what is that? 1 over x to the positive 5th. Okay? And then if I have x to the 0, anything to the 0 power is 1. Okay? All right, so those are the exponent rules that I was trying to get you to remember. Let's do some problems that use those. Okay? Yeah, we're recording here, so we're online. Can you guys see that, or do I need to go a little bit bigger?
Bigger.
Bigger? I can go bigger, that's fine. More? More? Ah, there we go. Nope, that's going to be totally good. Nice, now we're talking. Okay, so let's do some problems here. All right, so we need to simplify this. So this now is what you start to write down. Okay? So we're going to simplify a to the negative 2 b squared c over a to the second b to the negative 3 c squared. So since I am dividing, based on the conversation, the brief conversation we just had, what do I do with the exponents? I subtract them. I subtract them. So a to the negative 2 divided by a to the 2, I subtract these exponents. What is because what is negative 2 minus 2? Negative 4. So my first piece is going to be a to the negative 4. Okay? What do I do with the exponents when I have b squared over b to the negative 3rd? I subtract them again, good. And 2 minus negative 3 is 5, yes.
Why?
Because a minus a negative becomes a positive.
Hey, there's 2 positive 2s. I know you're not smart.
Okay, so since 2 minus negative 3 is 5, this will simplify to b to the 5th. Okay? Hey, Francis, you guys in the back corner, you got to pay attention here. Brandon. All right, now for this last one to simplify this, hush. This c right here has an exponent on it, even though it's not written. What is it? 1. It's a 1. Excellent. So now when I subtract 1 minus 2 is negative 1. So that would be c to the negative 1. Gillen, did you have a question?
Yeah, so
I'm not talking to you.
for B.
For b,
Yes.
this one right here, okay?
Okay, so wouldn't it be negative 5?
Nope, because I'm going 2 minus negative 3, right? So these two negatives cancel each other out and become positives. So 2 plus 3 is positive 5. Okay? Okay? But see, she's being reasonable with me. You guys are like freaking out on me back there. Yes, Brianna.
Okay, so let's see.
Okay. So, Brianna makes a good point there. We're not done because we have negative exponents, right? So I need to switch this around. Okay? Shh, shh, hey, shh. Guys, Cheyenne. I need way better attention than I'm getting from you guys right now, from the back corners of the room. Okay? Let me just talk. Let me just see. That's not helping. Okay. The b has only a positive exponent, so I do not need to change that. I'm going to leave it right where it is, okay, on top. Okay, I'm sorry, my board freaks out when I do this. All right, the a has a negative exponent on it, so I need to put it on the bottom and make the negative exponent be positive. Okay, just relax. The c also has a negative exponent on it, so I'm going to put it on the bottom and make its exponent positive as well. Okay? Now I technically don't need to write that 1 in there, but I can. My final answer to that problem is b to the 5th over a to the 4th times c. Okay? Yes, this part here right there, and I said that. Okay? Nate. No. No. Paige, do you have a question? Okay. All right, let's keep going. Paige. Trying to help you guys out here, okay? You have to pass this test, most of you, in order to graduate from high school. Okay? Trying to make your lives easier, and you're fighting me. Okay? Quit.
Making my life more stressful.
I'm not doing it. Okay? The state of Washington has made it more stressful. Okay? But I'm trying to ease it, and you guys just are not with me.
We want it to be easy.
Nate?
Will this grade affect our class grade?
No. Okay? But this thing that you're working on right now will.
So if I was good, what's the lowest grade?
Okay, I'm not going there. I want to help you learn math. Okay? All right, next thing. Graham, sit, please. I want you to sit. Okay? Yes?
Why don't we need the ones?
Because if you just write X, it's assumed that there's a 1 there, whether you write one there. What do you mean, why don't you use the 1? What
I
one?
make them positive. Because remember when you put them at the bottom, you just put 1.
Oh, okay. So you want to write a 1 right here? Okay, you can, you don't have to. There's already something on top, so you don't have to. Okay?
So as long as there's something on
But you don't have to write the 1 if there's nothing on top of either one. Okay. Hey. Okay, next one. And hopefully, while I've been having these discussions with Jolene, you guys already have this copied down. Okay? I'm going to go, this whole thing in parentheses, 20x squared y over, that's 5 to the first xy cubed, and I'm raising the whole thing to the second power. Okay? All right, so the first thing that I need to do is I need to raise the 20 to the second power. What is 20 to the second power? 400. Good. Yep, the whole thing is in parentheses. Okay, now this is where our rules of exponents come into play. X to the second power is what? X to the fourth, because you multiply exponents when it's a power to a power. Okay? Y to the second power is obviously just y to the second power. Okay? So that's what's on top.
I thought there was a 1 there.
On the bottom, 5 to the first to the second power. Well, what's 5 to the first? 5. And what's 5 to the second power?
25.
25. So we're just going to write that as 25. Okay? Okay, what about x to the second power? Let me finish. That's x to the second. And then y to the third to the second power is y to the sixth. Okay, I am not done. I need to simplify more. So do not ask me weird questions about why didn't you do this. Okay, so let's keep going. Now I need to simplify this. Okay, so the first part is easy. What's 400 divided by 25? 16. Okay, so that equals 16. Okay, x to the fourth divided by x squared. What do I do with the exponents? If you want to answer a question, I'll tell you, but if you're asking what, I'm not going to. Hold on. What is x to the fourth divided by x to the second?
2.
X squared. Okay? All right, now I'm going to do something that's going to totally freak you out. I have y to the second divided by y to the sixth. I do not want to make that negative because then I just have to put it on the bottom. So I'm going to do the bigger number minus the smaller number. What is 6 minus 2? 4. And since the bigger number was on the bottom, it is y to the fourth on the bottom. So that is my final answer. 16x squared over y to the fourth. No, it's okay. Francis?
Okay, so on the top one you subtracted, on the bottom one you subtracted.
On the top one I subtracted, on the bottom?
Number 1?
No, I subtracted on that one too.
No, I'm with her because you did. That's what was my question. You subtracted the first time.
Yeah, and I subtracted on this one too.
No, you divided 4 by 2.
I what?
You divided 4
No. I went 4 minus 2 is 2. It just happens to work out to be the same answer as 4 divided by 2. But I subtracted. This is 4 minus 2 is 2. Okay, and that's where that's
400 minus 25.
Okay, no, why would I go 400 minus 25? Clearly that's a division symbol. Okay, so because those are numbers. Okay, I'm not totally changing the rules of math and saying now all of a sudden 400 divided by 25 is 375. That's not a thing. 400 divided by 25 is 16, always has been 16, always will be 16. Okay? The difference is that these are regular numbers and these are exponents. So the laws of exponents are different than numbers.
So you're
Okay?
always going to divide the real numbers?
Yeah.
Yes.
Dividing means dividing always and forever. Okay? Yes.
On like 5, since you added the other exponents, wouldn't you add 5 to the first to 2? So wouldn't
Where
it
did
be
I
5
add
to
the
the third?
exponent?
Like you, on here it says that you would add them.
Not in this case. That I would add them if I have x to the fifth times x squared. Then I would add those and get x to the seventh. Okay? But these are not, these are different bases. I'm not adding them. here I have one on the top and one on the bottom, so I'm subtracting.
No, I mean on the bottom one where it says 5 to the first, and then it's all over 2, wouldn't you add it together to be 3? 5 to the third?
5 to the first to the second is 3.
Wouldn't you add it?
When I'm doing power to power, I'm multiplying this. Okay? Okay, did everybody get that copy down? I'm about to make it go away and it's not going to come back. Got it? Okay. Okay. All right, let's try again. Okay, so this is a multiple choice one, and since we have to make it big enough so that people in Cleveland, Ohio can see it, it's hard for us to see all of the answer choices, but we're trying to simplify the square root of 18a squared b to the third, okay? So we did these before. I need a perfect square number that goes into 18 evenly. What is the biggest number that you know the square root of that goes into 18 evenly? Okay, 4 does not go into 18 evenly. 9. Okay, so that means I'm going to rewrite 18 as 9 times 2. Okay? Make sense? Okay? 9 times 2 is 18.
Okay, it makes sense, but why do you do that?
I'll show you in a second. Okay? All right, then I have a squared. Okay? And I'm going to break b to the third down into b squared times b. Okay? So I only want you to answer the question that I'm asking. Do you see that what I have written right here is exactly the same as what we started with? Okay? Because 9 times 2 is 18, and b squared times b is b to the third. Okay? All right, now I'm going to simplify that because I know the square root of 9 is what? 3. So I can now take that and take it outside of the square root. Okay? So I'm done with the 9. Square root of 9 is 3. Pulled it out. Done. Okay? What is the square root of a squared? A. Good, because the square root and the squared cancel each other. So I'm going to take this and take it out of the square root and write it as an 8. What is the square root of b squared? B. So I'm also going to take that and write it on the outside because the square root of b squared is b. Now what am I left with underneath the square root?
2b.
A 2 and a b. Okay? So which answer is the correct answer?
A.
A.
Oh, I get it.
Okay? You did?
Very good.
Yes.
The 3 out of 9.
Because the square root of 9 is 3. Okay? All right, let's try another one. Okay, now we're going to simplify 90 divided by 49. And so here's how we're going to do it, same way as we did the last one. What is the biggest number that you know the square root of that goes into 90? 9. How many times does it go in?
No, 10.
I don't know the square root of 10.
Oh.
I do know the square root of 9. How many times does 9 go into 90? 10.
Oh, just
So I'm going to rewrite 90 as 9 times 10. Okay? What is the square root of 49? 7. So I'm going to write that as plain old 7. Okay? Now, just like we did in the last problem, I can simplify this because I know the square root of 9 is 3. So the square root of 9 is 3. The 10 is still underneath the square root because I don't know the answer to the square root of 10 off the top of my head. So my final answer is 3 root 10 over 7, which is answer choice D. All you have to do. Okay?
Wait.
Okay, I'm making it go away.
Wait, could you redo
to what? What would the 10 reduce to? Because we can, but do you know the square root of 5? Do you- Well, you could write it as 3 times the square root of 5 times 2. But what's the point of that? Okay, I don't either, so I don't want to do it. The reason why the rewriting it as 9 times 10 was helpful is because I knew what the square root of 9 is, so I could pull that out and make it a 3. But I don't know what the square root of 5 is, I don't know what the square root of 2 is, so it doesn't matter. It's not a whole number. So it doesn't Not a whole number, it's a decimal number, but not a whole number. So I only want to mess with whole numbers here, okay? All right, so let's keep going here. So the next one, okay, now we are doing a cube root, okay? So what is the cube root of 125? What number times itself 3 times makes 125? And if you don't know the answer to this off the top of your head, don't feel bad, but make a guess. Yes, it's 5. 5 times 5 is 25, times 5 is 125. Okay? Okay, now I still have the x to the 4th to mess with. Okay? So what I'm going to do is I'm going to change that into, Marcus, I'm going to change that into x to the 3rd times x. Okay? Can anybody tell me why I did that? Well, what is the cube root of x to the 3rd? Yeah, you do. X. Just like the square root of a squared is a, the cube root of x cubed is x. So now I can take this and move it out also.
The cube root of x squared.
That we wouldn't be able to do. Okay? And then we're done. What? Nope, we haven't done a cube root, but guess what? Now we have.
We finished.
Brianna?
So why did you take 5 after this first one? I don't get why that's
Because the cube root of 125 is 5. Because 5 times 5 times 5 is 125. Graham? Yep. Because I took the cube root of it, so I did that part of the problem, so I pulled it out and done with it. Yes.
Where's the x?
The cube root of x cubed is x.
Oh,
Okay?
okay.
All right, anything else? We move on? Okay.
Why is the x still inside?
Because I don't know the cube root of just plain old x. All right, so now we're into the next set. So we're done with exponent stuff. Thank goodness.
Thank goodness.
We don't have to grab this.
Let's see what's going on here. Okay, so this is something that we have talked about before. Give the domain D and the range R for each relation. Does anybody remember what the domain is?
Oh, is it x
Right, the domain is all the x's, and the range is all the y's. So the domain of this stuff right here is -5, yeah, 0. It's as if you've never been in my class. Oh wait, you never. The domain is -5, 0, 2, and 5. Because the domain is another way of saying what is the x's. And then the range is the y's, so that would be, okay, right, but I want to write those in numerical order. So what's the lowest y value? -20? What's the next lowest one? 0,
7,
7, 8.
Yeah, I don't.
The domain already was here. If it wasn't, I would have changed it. Okay? All right, let's take a look at another one now that you know what you got going there. What about this one?
No, you need to write down the
Yeah.
answer.
Yeah, you bet. Okay, for B, somebody tell me what the domain is of that.
1, 2, 3, 4, 5.
Okay, easy stuff. Cheyenne, you need to stay with us.
Yes, I am.
They have to be in order.
Yep, they have to be in order from least to greatest.
Always?
Always. Siempre.
Okay. Yeah, it's the same.
How about the range?
2, 4, 6.
2, 4, 6, 8, 10. And luckily that already is in order. 2, 4, 6, 8, 10. Okay? So do you remember that? Domain is the x's, range is the y's. No big deal. Anybody want to panic about that? Okay, I'm going to erase this.
No, for fun.
Okay, you may, sir.
I'll go ahead. Guess
What
what?
is that? What?
Just to even it.
Okay, then you can also get the domain and range by looking at a graph. Okay? So if I look at this little piece right here, what are the x's? 0,
Hold on,
1,
1.
2, 3, 4, and then it stops at 4, right? What about 1.5?
That works.
What about 1.6?
That works.
What about 1.987325?
Works.
That works, okay? So I'm not going to be able to list them all out this time. Marcus, it's got to pay attention, okay? Pay attention. Okay, so what I do is I go parentheses 0, comma, 4. And what that means is all the numbers in between 0 and 4.
Oh.
Okay? What is the range then for the y's?
0, 4.
0 to 4, same thing. And I'm going to, since it includes everything in between as well, I'm going to write 0 to 4. Okay? So if it is individual numbers, you can list the numbers out. But if it's a graph or something, then you have to do the whole thing. Okay? What, Princess?
If the graph is like dots.
Right, if the graph is dots, then you list the numbers out because then it doesn't include the stuff in between. Good point. Okay, then you can also have this shown to you in a table form. And this is super, super easy because the domain is the x's, the range is the y's, so it pretty much gives you the answer. What's the only thing we have to do? Put them in order. So 1, 2, 3, 5.
Five so much tall.
I don't know, it's weird, huh? It's always a 5. 6, and then the range is
2, 9, 25, 36, 81.
Well, how large is that?
36.
okay. So do you guys remember domain and range now?
Yeah.
Okay. Can I?
Wait, not yes.
Yeah, please.
I'm pro at this.
I think you should quiz Paige.
You think you should what?
Quiz, I think you should quiz you.
No,
And
no.
none of us just heard this.
Yeah.
Okay, next one. There are a couple of different ways that we showed these. We did a table, we did a graph, and then we did the mapping diagram. I don't know if you remember that, but that's where we made like a big bubble, and we wrote the numbers in here. You remember this?
Yeah.
And then we drew like arrows over to this other bubble. That's called a mapping.
Can we do the table?
Yeah, probably your most favorite way would be a table. So how would I write this in a table? I'm going to make an XY table. Okay, so what do I put in the X column? -2,
5.
0, 2, and 3. Okay.
7.
And then the y's, now this time, those are just the x's. So this time, since the x's and the y's are paired together, I'm not going to write them in numerical order. The 5 needs to stay with the -2, so I'm going to put a 5 right here. Okay, the -1 has a -1 with it. 0 goes with 4. This goes with -2. And this number right here, which is a 3, goes with a -4. Okay? So if they give you the ordered pairs, then you have to keep them in that same order as you go. Okay? All right, and then you get the idea, so we can do the same thing for B, right?
No.
And I'm going to do it, just for funsies, I'm going to do it in a different way. No, but I want you to be familiar with this method in case it comes up. I don't know exactly what's going to be on the test, I just know roughly. So I want to make sure you guys are ready. So if I did this as a mapping, then I would just draw arrows because the 3 goes with each one of those things. Okay? So that's a different way to show that information. And if you wanted to graph it, you guys all know how to graph, right? Okay, let's do one more thing.
Can we done for the day?
And then we can, are we out of 30?
Mr. Aldrich, I heard that yesterday during class when I was at Carrie, you showed a video of Kobe.
That's not true.
Got very offended.
That's not true. Okay, now we have to decide whether these graphs represent a function or not. What's the key to doing that? Do you remember the pencil test or the vertical line? Yeah, the vertical line test. If you can draw a vertical line that's going to cross the graph in more than one point, then it is not a function. So is this a function right here?
No.
No, because it fails the vertical line test right there. So this first one is no. Fails the vertical line test.
How does it show them?
Because if I draw a line right here, straight up and down through the graph, that vertical line crosses more than one point on the graph at the same time, does it not?
I don't know.
Yes, it does. How can you say that? What? Well, it can only hit one for the answer to be yes. No. Here's my graph right here, and it's hitting all of these points.
Like every little square, you mean?
I mean, if I draw a vertical line, it can only cross the graph at one point.
So it can only be one square long.
I can't even be one square long. It can only be 1 point long. Let me do this one so you can see what I'm talking about.
No.
Is there any way that I can... Is there any way that I can draw a vertical line, Allie, that will go through this graph in more than 1 point? Where? No. I'm not understanding what's happening in your brain right now. If I draw a vertical line right here, how many places does that cross the graph? Once. Why did you say it can have more than one?
Because you can draw 3 different lines.
No, but it has to be one line that crosses more than one time. Okay, so...
Yeah, I don't get it.
You guys are making me, did you guys all get together before class and say, let's play a joke on Mr. Aldrich? Let's ask him crazy, bizarre questions all period long?
That's how I feel you're doing right now.
Okay, here's my line. This pen is my line, okay? Does it cross the line more than once? No. If I move it over here, does it cross the line more than once? No. If I move it over here, does it cross the line more than once? No. Okay, so since the answer is always no, that means that this is yes, a function.
Why is it yes?
Okay? Because it never crosses more than once.
It's a rule.
Oh my God.
It doesn't matter why, it's a rule.
Okay, this is my line right here. When I draw the line right here, does it cross this graph more than once?
Yes.
Yes, it crosses it an infinite number of times.
Oh, wait, I thought they...
Because if it crosses it more than once, then it is not a function.
Because it only crosses it once.
Is it